Look at the class. All right. I was going to have a sub today, but I guess we'll... All right, Scruff. Out of the picture, man. Oh, look at all the hair on this thing. Okay. Woo! Oh, that was fun. All right. I don't know why I'm wearing this, because I think this mic... Do you hear, like, tapping on the screen? Is it, like, loud? Do you hear me at all? Can anyone hear me? No one's responding. No sound? No one can hear me? Oh, okay. That's the first time someone said something. All right. Okay. So I got the screen here. Might as well get going. It's 12:06 or 2:06. Good old start with the calendar. So we'll look at that. I did do this 3-2 as an ed puzzle, but it's not really an ed puzzle. It is an ed puzzle, but I didn't do any questions. And those that actually watched it know that. Now, as on my end, it doesn't show any percentages. It just shows a bar that you watched it. Which I do kind of like that. That's okay, I guess. Because I did want to use a video just from last year and not redo it. So I do like those because you can hear the classroom in the background. And anyone that did watch it, there's a little punk in there that says, nope, I don't want to start the video. I don't know if you can hear that. I know who it was, too. He's kind of funny. So, but you can just hear a classroom and you're talking. You hear, just miss that stuff. That was about a month before we closed, probably, when I made that. So, I just like going back to that and just hoping that that comes back shortly. Probably won't be by the end of your senior year, but hey, maybe in May we can have some groups and people interacting and all that other stuff. Let's hope for it. Now, I did put this unit circle here. I don't know. Oh, you know what? I'm not presenting, am I? And no one even told me. Way to go. Good job, everybody. All right. So we'll present. I'm already taping, so I got my substitute teacher in there for a moment. Good. I'll get the chat because I do want you to answer maybe some questions today. So now we're presenting. I put this unit circle on there. Boy, I really don't want you to print it. Maybe print it and look at it because it's beautiful. Maybe put it in the frame. I did make this years ago and put the fancy little colors to coordinate what we discussed on Tuesday, trying to think of the day, that all over 6s in red here are 30s, right? All blues over 4s end up being 45s, right? All greens are over 3s. They end up being 60, 39, right? And then I put the quadrantals in gray. Nice color coding if you have a nice color printer, but don't get used to looking at it when you're doing your homework because you're only causing yourself damage probably. So it's nice to look at and kind of get a feel for it. I'll show you what you really need to be doing when you're seeing the questions that you see. Then I did put this worksheet, so I'm knocking around. What do I want to do today? What are we ready for? I think you are ready for this worksheet. So I opened it up to just kind of go through it with you. Look at, I love how this CUDA software did these kind of questions where cotangent of -675. For those that are struggling, got some angle measures and degrees from chapter 2. This is what you're supposed to figure out. It's -360 and then plus another -315. All right. So there's the drawing of it. Then all you'd have to do is complete the triangle and put your side measures for that. So yeah. And then 11 pi over 3, so that's what we're going to be really hammering down today. The idea that the only problem with radians is fractions. Those that are fractionally challenged are the ones that have a problem with radians. Because 11 pi over 3, that's 6 pi over 3. 6 pi over 3 is one rotation, 2 pi, and another 5 pi over 3. Hey, in the chat, I already said this, what's the reference angle? Hold on. 5, 4, 3, 2, 1. Come on, be better than 6th hour. Oh no, you're not. I got nobody in the chat tell me what the reference angle is. For an over 3, what's the reference angle? Now, anyone? I'm not moving on until someone tells me what the. Thanks, John. Otherwise, this is going to be awfully awkward. right? So we know it's a 60 because it's an over 3, and then, we can go from there. And that's what our notes will go through today. Then on the next page, whoa, look at that one. 16 pi over 3. Woo. Okay, and then without a drawing, you're on your own. Okay, then this is what I'm going to help you with. Actually, these last ones, including a calculator question at the end here. So I'm just going to continue on and just make up questions. Nothing special for notes today. I'm just going to make up stuff out of my head. So here's the first one. I lost my pin. That was my fault, not the computer's. Sine of theta. Oh, sorry. The directions are. I need all answers from 0 to 2 pi that make this work. Okay, so I'll just screenshot that one more time. So that's all it says. Happy, and then paste it. Boom. Okay, now, do you remember that you already had this question, but it was worded this way? Solve for all thetas between 0 and 360. And then that implied that you had to have your answer in degrees, and you've already been tested on this. Okay, felt like I was getting that cramp again. Was that 7th hour where my arm cramped up very awkwardly? Was it? Was it this hour? Oh, felt like it was coming out again. Maybe it's you guys. Okay, now I'll tell you what you would have to do in calculus if you were juniors and then you took calculus as a senior, which used to happen in this school. But no more drawings. No more drawing triangles. You'd have to know the answer right away. So I'll show you how you do that. First of all, in the chat, let's do better, please. Come on, just try to make a guy happy here. What's -1? What letter is that? 5, 4, 3, 2, 1. What letter is that? Oh, this is just like 6 hours. John again. Is that an I, Jeremy? Okay, I thought I saw an I there. All right. So it is Y. All right. You might have hit I is 2 away from Y. Maybe you made a mistake there. Then I want to ask you this. This is R. This is why you should know what this is. Y is not, or the Y coordinate is not only always the opposite side. I mean, it is, but it's always opposite the reference angle. So it's just, once you find out what Y is, you know what the reference angle is. So in the chat, what side, wrong, what angle is always opposite 1 in 1, 3, 2, 5, 4, 3, 2, 1, go. Lindsay, Gladys. And I guess that's it. Okay, so this is a 30. So this is what a calculus student's got to do, like fast. Not only is it a 30, it's a 30 in which quadrants? Playing ACTC in 5 seconds, what quadrants are we in? 5, 4, 3. What quadrants are we in? 2, 1, 0. What quadrants are sign negative? Oh, no. Maybe we just don't know these answers yet. John, Adriana, Julia. Nice. Thank you. I do appreciate it. So a calculus student does no drawing. They play all students take calculus, and they know Y is always the dictator of what the reference angle is. That's what ends up happening. Okay, and then real quick in the chat, as I just intimated up here, and fine, I will do the drawing after this for those that are, that need it. Jumping ahead, trying to get to, those that are ahead of the game here. So what's the denominator of a 30-degree radians measure? 5, 4. What's the denominator? 3, 2, 1, 0. Lindsay again. Lindsay, you just do it all day long, man. At least I got somebody, right? Then over 6. 6 hours the same way. We're just like this. I'm not answering anything. And over 6. Okay, we should know that from Monday, Tuesday stuff. Okay, so here's what we do. All right, fine. I'll draw it. The triangles are out. Program is so. Okay. -1, 2. That's why it has to be in either quadrant 3, -1, 2, or quadrant 4. And then, of course, this has to be root 3 because of the Pythagorean theorem. I always said quadratic formula. I don't know why. And yes, that's a 30. And yes, that's a 30. That always happens. And then 30s are over 6s. Now, this is the next thing. This is why you don't print that unit circle. You can look at it, like I say, but then just get away from it. Because this is pi, the game I played with you Monday or Tuesday. And pi is, I'm not asking because I get sad that people don't get this and don't understand why I'm doing this. That's equal to 6 pi over 6. So what is the numerator of this answer? If this is 6 pi over 6 and then a little bit more, 30 degrees, what's that numerator? 5, 4, 3, 2. Adriana, 1, 0. Okay, well, Adriana, let the cat meow out of the bag in cat class. And then 2 pi is 12 pi over 6. This does make me sad how many people don't know that, like where I come up with that. So what is this numerator? Adriana, slow down. 5, 4, 3, 2. It's a little bit smaller than 12. 1, 0. Thanks, Lindsay. Back to you, Julia. Great. Blanca, nice. 11 pi over 6. So that's how I do this. That's how I know this. This is easy as it gets, you know? Okay, so that's why I don't need that unit circle. I just compare fractionally. Okay, so let's say cosine of theta. I really like doing the negatives just because you're getting different quadrants with that. Negative root 2 over 2, let's say. Let's do another one. Same directions. All answers from 0 to 2 pi. This would be no calculator because we recognize this ratio. By the way, in 5 seconds, what is the reference angle? 5, 4, 3, 2, 1, 0. Just Lindsay? Adriana, 5? Never heard of that. Is that a mistype? Okay. Because we've dealt with this forever, we should know root 2 over 2 is the 45 degree reference angles. But if it would help, we would want to make this, it is actually negative 1 over positive root 2. This came from this. So this is x, but you know what? Y is also equal to 1. 1, 1, 1 root 2. And what's opposite 1 is a 45. So we know right away it's a 45. And then what quadrants is cosine negative? Let's put that in the chat in 5 seconds. What I want you to do is load up the answer. Don't press enter yet. I want to see how many people get this right. Where is cosine negative? What quadrants? 5, 4, 3, 1, 0. Right? Some people taking some time. Good. Some people probably waiting for others to answer, then copy those answers. I'm just kidding. Don't want to take any credit away from you, but I thought it'd be like, you're right, 2 and 3. Because A, S, T, C, not here and not here, because that's where cosine's positive, and I have a negative, so it's 2 and 3. Okay, and then just if you want to see the construction of the triangle, if you're liking the triangles, it's because this is negative 1, 1, root 2. Oh, and negative 1 down and then root 2. That's why it's these two triangles. And it is 1 and negative 1 for our opposite side, so it is a 45. All right, not getting as many as I want in the chat. I think just some people are refusing to do it. So we'll just cut that off. And then just answer to yourself, what's a 45? It's an over what? Okay, hopefully you answered yourself 4. And then the next thing you do is put pi here, which is 4 pi over 4. Jump backwards, 3 pi over 4. Jump forwards, 5 pi over 4. That's as hard as radians are. Okay, and that's the answer. So, do I need the triangles? No. This is all a calculus student would do. They would just have this analysis in their head. They'd analyze this and then know just by thinking, ASTC, I'm in quadrants 2 and 3, and it's a 45. They're over 4s, 4 pi over 4, 3 pi over 4, 5 pi over 4. Bam, done. Done. Okay? Hopefully you can get there as fast as possible. Okay, so we're at 220. I hope this isn't on the worksheet. We'll do a positive. If it is, well, good for you. Questions for you. Okay, so if you start labeling your triangle with root 3 and 3, you're going to be confused. and you're not actually going to recognize this as a special. Okay? Attendance, terrible with attendance today. Check my email, look at the report for my other classes. Sorry. Ugh, this is all in the video. Hey, the dog made the video too, so if you want to, show that to your friends. Sub today. All right. It comes from 1 over root 3. That's what root 3 over 3 is. And then I'm done with the chat. Done. We only have 9 minutes. You should know this is x over y. Then you should know it's over. Okay, fine. In the chat, 5 seconds. What's the reference angle? 5, 4, 3. Come on. 2. Go ahead and do it. 1, 0. Jeremy, I should be making you answer all these questions when you left my class right before it was your turn to answer a question on Tuesday. You guys remember that, right? Oh, all of a sudden, Jeremy disappears. Oh, let me guess. Your internet was bad. All right. Never mind. Okay, good. So I see everybody. Nice. Hey, Julia. All right, good. Good question there. All right, so root 3, 60 degrees. Nice. Okay, 1 root 3, 2. So that's why we don't really need the triangles anymore. And I'm not even going to draw the triangle. ASTC. I'm dealing with quadrants 1 and 3. That's where cotangent's positive. So I have a 60 in 1 and a 60 in 3. 60s, I'd ask in the chat. 3, 2, 1. What is it over? It's over 3. The quadrant 1, 1 is just pi. So there's one of my answers. What's the quadrant 3, 1? 3 pi over 3. So jump forward, 4 pi over 3. That's how you do it. Simple as that, right? Got one more of these. That's a special. And then we're going to go into some calculator work. And sine of, this is a trick. Sine of theta equals 0. Oh no. This one's a rough one. By the way, 0 over, think about it, don't put it in the chat, I'm done with it. 1. I hope you were saying that. Okay, so you do have to, when the sine of theta equals 0, you got to put 0 over 1 so you know your sides. Then you know that this is y and this is r. Okay, fine, back in the chat. What would x have to equal? 5, 4, 3, come on, 2, I'm begging you, 1. I just said the answer, 0. Yep, good. You know what though? You're all wrong. Aw, this is why I don't go into chat, Mr. Samuelis. Plus or minus, right? If you actually did the Pythagorean theorem, you put x squared unknown, y squared known, equals r squared known, and then you would have to square root both sides, and when you do that, you do get a plus minus. That's the trick in this one. Because now you have to understand this is not a 45, this is not a 30, this is not a 60. This is 1, 0 is one of the coordinates, and negative 1, 0 is one of the coordinates. So this is actually 0 and pi for radian measures. 0 degrees, 180 degrees, 0 radian, pi radian. There is no triangle for this one. It's one of those special cases of a quadrangle. All right, so a lot of times people don't do the plus minus, and they may only say 0 and only give me one answer. You got to be careful on that. That's the point over that one. Okay, and then I'm going to cheat. I got to look at what I did there. 0.9641, 0.9641. Move out of the way, Mr. Samuelis. 0.9641. I think it was cosine of theta as well, equals negative 0.9641. I just don't have to retype on the calculator. Now you can see that why this is not a no calculator question, which means it's a calculator question, which is how I should have said that. This is a calculator question because this is all crazy. This is not root 2 over 2, root 3 over 2, those special little answers. So I'm going to start by talking about this, and then we'll go from there. Your buddy Joe left now, Jeremy. It's either you or him that end up leaving early. You guys take turns. So we're going to go to the calculator. I did this first, though. I did this in degrees. So look at this up here. I left my calculator in degrees. Now I have it in radians, as you can see. But in fifth hour, I did this in degrees just because people make sense out of this answer. Inverse cosine of negative 0.9641. By the way, that's a ratio of sides. Cosine of theta equals a ratio, x over r. So you inverse cosine it to get the angle measure. And I think everyone would understand 164.6 is in quadrant 2. So that is the terminal side there. Everyone makes sense out of degrees. And I did this in fifth hour. I went to my calculator and said, all right, let's put it in radians. And then do the same question. And then you get this answer. Weird. Well, everyone should know that 2.87, maybe not yet, but should know this is in quadrant 2 because pi is 3.14 radians. Or both me and the people that showed you where a radian came from, that's 1 radian. That's approximately where 2 radians was. That's approximately where 3 radians were when we did the taking the arc and overlapping it on the circle. So sure, 2.87 radians should be in quadrant 2. Now that makes sense a little bit. But Houston, there's a problem. Look at the directions on the worksheet for this section as well. I want all answers from 0 to 2 pi. It's the same as this section here. There's 2 possible answers. Your calculator only spits out 1. You have to come out with the other one. So this is an ASTC scenario. ASTC. So I have another angle that makes this work that's in quadrant 3. How do I find that with my calculator? Well, there's a couple different ways. I will say this, that whatever this reference angle is that we can find, that, subtract pi minus this 2.87, that's the same as this reference angle. So that will be true. But I have a better way. This measure right here is actually negative 2.87 there to get the same terminal side that gives me the same reference angle here. All right? So that's why on my calculator, on this one, I did 2 pi minus this answer to get 3.41. Right? And then what I should do is this. Watch this. You do know that this is an angle measure in radians, right? If I cosine that answer, I am going to get close to this answer right here, which is the ratio of sides. Boom, shakalaka. It's actually spot on. So it's proof that 3.41, that angle measure, the cosine of that also gives me that ratio, negative 0.9641. Okay? So 3.41 is the other one. So I got 2.87 radians and 3.41 radians. I think we're going to need some more work on the calculator one because some crazy stuff happens. What the calculator is able to spit out as answers and how you're supposed to analyze it. So unfortunately, the calculator questions are not just copy a screen answer. You actually have to know what's going on. So, okay, so we'll leave it at that. Thanks for those that answered in the chat. And I'll just leave it at that. Hasta la bye-bye.